In this video, we are going to discuss about some possible question from another important topic from the chapter carbon compounds, that is homologous series. Okay, let's see what all the possible questions that can be asked from this topics. I have listed out a few questions. Okay, so first thing you can expect is to define homologous series, to write a definition for homologous series. Okay, that's the one question you can expect. Then you can expect define homologous series with an example. So study some examples for homologous series. Okay, and also you may ask you may given with a few compounds, and you may ask to prove that the given list is a homologous series. So if you look at this question, how will you prove that C4H10 and C5H12 are homologs? So you'll be given with few compounds, and you may ask to prove that this is a homologous series. So you have to write the conditions to form a homologous series. And you may also ask to write the few characteristics of a homologous series. Okay, then another important questions will be you'll be given with a list of compounds. You may ask to find out the homologs from the given list. Okay, out of the given list, find some possible homologous series. That's another type of question you can expect from this part. Then you'll be given with one compound. What is the formula of the next homolog? What is the next homolog, or what is the preceding homolog? Okay, all this can be possible. Then you may ask to generate a homologous series with a particular functional group. Write first four members of a homologous series with COH functional group, or OH functional group, or CHO functional group. All these questions are possible. Okay, so we'll discuss one by one. Okay, so first, to define homologous series. So how can you give a definition for homologous series, or what is a homologous series? Okay, so look at the first series. Okay, it's very clear that all these compounds are belong to which family? Alkane family, right? Alkane family. What is the general formula of alkane? Cn. If there is n carbon, the number of hydrogen will be double plus 2, CnH2n plus 2. Okay, so you can see all these compounds, okay, are satisfying the formula CnH2n plus 2, right? One carbon, double plus 2, 4 hydrogen. Two carbon, double plus 2, 6 hydrogen. Okay, so all these are satisfying the general formula CnH2n plus 2, right? And if we see how these adjacent members are, what is the difference between the adjacent members? If you see the difference between adjacent members, what extra here from CH4 to C2H, there is an extra carbon, there is extra 2 hydrogen. So if you see the among the successive members, the difference is CH2, right? In between each members, they differ by 1 carbon and 2 hydrogens. Okay, so if these two conditions satisfies, the two condition means all the compounds should belong to same family, same category. If one is alkane, everything should be alkane. Okay, if one is alkane, everyone should be alkane, and the adjacent members or successive members should be differ by CH2. If these two conditions satisfy, we can call a series as homologous series. Okay, look at the second series. As you can see, it has a general formula CnH2n. That is, if there is n carbon, there will be double hydrogen, right? When there is 2 carbon, 4 hydrogen, 3 carbon, 6 hydrogen. So generally we can write, so this is the alkene formula, right? So it's very clear that they are all belong to the alkene family. Okay, all these are alkenes, right? So they belong to same family. And if you see there difference between the successive members, okay, again the difference is CH2. Among them, the successive members are differed by CH2. Okay, so this is also a homologous series. Okay, look at the third one. Okay, what is a common thing in that? You can see there is a common thing, that is the functional group OH. So we know that compound containing OH functional group we called alcohols. So all these compounds are alcohol. So they belong to which family? alcohol family. Okay, and if you see the difference between their like successive members, again the difference is CH2. They differ by adjacent members are differ by CH2. So they all belong to alcohol family, and the successive members are differ by CH2. Okay, so this is it's also same thing. So now what is a common thing in this series? Okay, so if you're given with a series, first check that whether they have a like a general formula, they belong to same family or not. Okay, general formula, they should belong, they should have a general formula, or they should have a common functional group. That's the first condition. Common functional group. Okay, so look at the first series, all are alkenes, right? So they have a general formula CnH2n plus 2. Second is like all are alkenes, they have a general formula CnH2n. Third series, all are having OH functional group and having a like a general formula or like having a common functional group, and the adjacent members are differ by CH2. Okay, so if any series, a series means it should be have minimum 2 compounds. Okay, a minimum of 2 compounds. So you can say that how you define then homologous series? It's a series containing like 2 or more compounds, or a series having a general formula or a functional group. Okay, so you can, for a 1 mark, you can write this definition: a series of compounds. Homologous series means it's not one compound, right? There is a number of compound is present. It's a series of compound. Okay, it should be more than one. Okay, 2 or more compounds. Okay, so you can write a series of compounds having a general formula. Either they should belong to, general formula means they belong to same family. Okay, so general formula or a common functional group, and the adjacent members or successive members are differ by CH2. Okay, so you can write any of this definition. Either you can write a series of compounds having a general formula, or you can write a series means minimum 2 compounds should be there. So you can also write 2 or more compounds having a general formula or functional group, and the successive members differ by CH2 unit, can be a homologous series. Okay, so both conditions should satisfy, which means they should have the first condition is that to form a homologous series, the first condition, they should belong to the same family. Okay, the same family means if one is alkane, everyone should be alkane. Okay, they should have a general formula, or there should be a common functional group. That's the first condition. Okay, but a second condition, the adjacent member should differ by CH2 unit. So these are the two conditions they should satisfy to be a homologous series. Okay, the adjacent member should differ by CH2 unit. If these two conditions satisfies, you can call a series. Okay, minimum 2 compound is required to form a homologous series. For example, like C2H4 and C3H6. So you can see this is a homologous series. Even so, there are 2 compounds are there. They belong to alkene family, and the difference is CH2. So there can be a homologous series. Okay, so anything satisfy this condition, like this definition, can be a homologous series. Okay, clear? So if you ask like an examples for homologous series, you can write any of the series. Okay, you can write alkane series. Alkane series means which have a general formula CnH2n plus 2. So you can write CH4, C2H6, C3H8, etc. So they forms a homologous series. You can write alkene series, which is having a general formula CnH2n. So if anyway, minimum like to form an alkene, what is the condition for alkene? Minimum there should be a carbon-carbon double bond. So there is no alkene with 1 carbon. So minimum there should be 2 carbons. So C2H4, C3H6, C4H8. Okay, this also etc. That's also an example for like homologous series. Then you have alkyne series YNE, where you have at minimum a carbon-carbon triple bond in the molecule. Okay, so if there is n carbon, the number of hydrogen will be double minus 2. Okay, so again to form a alkyne, there should be minimum 2 carbon. So the simplest alkyne is YNE is C2H2, then C3H4, C4H6, etc. They also form like a homologous series. Then you can also write a homologous series with functional group. Okay, Now we'll see how to write like a homologous series of functional group. Okay, so to write the homologous series of functional group, okay, you just remember the alkane series, because in the alkane series, like you have like all the bonds are single bonds, okay, where one carbon is surrounded by four other atoms, right? So remember, like in an alkane, you'll find only carbon and hydrogen, right? Carbon and hydrogen. In a functional group, okay, some other atom is coming other than carbon and hydrogen. So functional group basically means, what is a functional group? A functional group means any group containing a heteroatom. Heteroatom. A heteroatom means, okay, an atom or like other than carbon and hydrogen. Other than carbon and hydrogen, okay, anything comes, we call like such atom, we call heteroatom. Any heteroatom is present in a like a group like which is coming and replacing hydrogen, we call it functional group. Okay, so we know OH. So here, what is a heteroatom? The heteroatom is oxygen, CHO. What is a heteroatom in this? It's oxygen. C double bond O, the ketonic group. Okay, the heteroatom is oxygen. COOH. Here also the heteroatom is oxygen. Okay. Then in halogens like Cl, Br, all these are heteroatoms. Okay. Understood. So any group containing a heteroatom other than carbon and hydrogen, we call it functional group. Okay. Now, how to write the series with functional group? If you want to write any series with functional group, the first thing you should remember is, okay, the functional group is coming by replacing hydrogen. Okay, it is coming by replacing hydrogen. Okay, so if you want to write an alcohol series, okay, what you can do, just think of, if you want to write a one carbon alcohol, think of the one carbon alkane formula, it is CH4. Okay, now you replace one hydrogen and in that position OH will come. So what is the first alcohol? CH3OH. Now if you want to write the second alcohol, think of the second alkane formula, C2H6. You replace one hydrogen, okay, there one OH comes and occupies. So that's the second alcohol. If you want to write the third alcohol, think of the alkane formula, okay, you replace one hydrogen, reduce one hydrogen, instead of the hydrogen, you will have OH, okay, etc. So that's the one carbon alcohol, two carbon alcohol, three carbon alcohol. So you can easily write the series just by replacing one hydrogen with the functional group. Whatever be the functional group. Okay, suppose I want to write a haloalkane series. So for example, I want the chlorine. Okay, so a chlorine comes on alkane, like we call it like chlorine is a halogen, right? The group 17 elements are called halogens. Group 17, that includes chlorine, bromine, iodine, fluorine, all these are halogens, the group 17 elements. Okay, so if the halogen comes in an alkane, we call it haloalkane. Anyway, naming is deleted. So, but it's very easy to write. Okay, just think of the alkane formula, replace one hydrogen. Instead of that, you can write the halogen. So CH3Cl. C2H6 become, replace one hydrogen with the Cl. Okay, from C3H8, replace one hydrogen with Cl, etc. That's a haloalkane series. If you want to have an aldehyde series, you know what is a functional group. Aldehyde functional group is CHO, right? So replace one hydrogen, you can add a CHO. Okay, and again from the second one, you can replace one hydrogen, C2H5, you can add CHO. Okay, so again you can from the other one like C3H7 CHO, it goes like that. Okay, so if you check like all this, the difference in the adjacent members is only CH2. Okay, and they're all having a common functional group, so they're all homologous series. Okay, so this is a 2 carbon aldehyde. Okay, if you want to get an aldehyde like the next homolog, now I want the preceding homolog. Okay, so what I can do, just subtract CH2 from this. So what is the first? The CHO remains. If you CH2 goes from CH3, you'll get HCHO. That's the first aldehyde, because the functional group itself has 1 carbon. So this is the first aldehyde. Okay, so I hope it's clear how to, all these examples can be written for like as an example of homologous series. Okay, then another type you may ask like any two characteristics of like homologous series, or like some number of characteristics of homologous series. Okay, so what can be written? So generally we know that homologous series having a common formula. Okay, a common formula or a general formula. or having a common functional group. Okay. And another like characteristic you can write, they differ by CH2 unit. That these members differ by, write that these members, okay, that these members differ by CH2 unit. But that's actually comes under the definition of homologous series. Okay, what are the property of homologous series? So mainly you can write, if one compound is alcohol, okay, the entire compounds are alcohol, right, in that series. Okay, so which means they all are alcohol, so they like they're supposed to show a similar chemical property. So their chemical properties should be same, but they're all different alcohols, so their physical properties do changes. So you can write they show similar chemical properties, but they like their physical properties will be different. So other than this 2 point, you can write about their physical and chemical properties. Okay, understood. Now you may ask to prove that a particular you'll be given with 2-3 compounds, okay, whether they can form homologous or not. Okay, so look at this example. You have given with 2 compounds, C4H10, C5H12. It's very clear that both belong to which form, which general formula? CnH2n plus 2. So they're all like both belong to the same formula, that is, which means both are alkanes. So they belong to same family, and they look at the difference, they differ by CH2 units, so they are homologous. So both condition has to be satisfied. Okay, first they should have a general formula or functional group, or they should belong to same family. Second is they should differ by CH2 unit. So if you like write these 2 points, and if the given compound satisfy these points, you can call it as a homologous series. That's another type you can expect. Now this is like another important type. You may be given with a formula, and you may ask to write the next homolog or preceding homolog, like that. Okay, so first identify like what will be the question, like what will be the compound is given, whether it is alkane or alkene or alkyne or alcohol or aldehyde. Okay, you to get the next homolog, okay, it's very easy, just add CH2 with it. Okay, that's it. If you want to get the preceding homolog, just subtract CH2 from the given compound. So if you have C2H4, the next homolog is C3H6. Here it is, just add CH2. Okay, if you add CH2, you'll get C4H6. Okay, this is, you don't want to check whether it is alkane or alkene or alkyne. You can simply add CH2 and write the next homolog. Okay. What's the point? If you ask to write the next homolog or a preceding homolog, okay, if you want to write next homolog, add CH2 with it. If you want the preceding homolog, subtract CH2 from the, for example, if C3H4, okay, what is the preceding homolog? The next homolog, you can add CH2. Okay, so you'll be getting like C4H6. What is the preceding homolog? You subtract CH2, so C2H2. So in either way you can do. Okay, you can find the next homolog as well as the preceding homolog. Okay, clear? So look at this question. What is the next homolog of C3H7OH? So you don't want to worry about the like formula and all. Just add CH2 with it. Okay, add CH2. So C4H9OH. Okay, that's the answer. Okay, it's very easy. Now we know that in a homologous series, okay, that these members are differ by CH2, right? A CH2 means it contains 1 carbon and 2 hydrogen, right? 1 carbon and 2 hydrogen. Okay, so carbon has a mass of 12 unit, okay, unified mass, and hydrogen is 1, so 2 into 1, so total you'll get 14 unit. So what is the mass of CH2? A CH2 unit has a mass of 14 U. Okay, so like if the homologous series, the individual members are differ by CH2 means the difference in molecular mass of their adjacent members should be 14. Okay, so look at this question. Okay, a molecular mass of a compound in a homologous series is 30 U. Okay, so what is the mass of the next homolog? So okay, you don't want to like find the formula of that, you just add 14 with it, because the homologous series members are differ by CH2. CH2 means it has a mass of 14. So next homolog will be 44U. The preceding homolog will be, you subtract 14, will be 16U. Okay, Clear? It's very simple thing, like the CH2 we are just converting into mass, that's it. Okay. Now, like another type, you can expect like you may ask to write the like first two members of a homologous series having a particular functional group, first three members, first four members, like that. So if you asked, so like we just think of like the first two members of alkane. Okay, so here you asked to write the first two homologous of a compound with a functional group like Cl. So what you just think of the first two alkane formula. So one carbon like double plus two carbon double plus two. So these are the first two alkane in the homologous series of alkane, right? So then how to write the first two like members of homologous series Cl? Okay, it's very simple. If you want a Cl here, the only way is you have to replace hydrogen. So just replace one hydrogen and introduce one Cl. Here also just replace one hydrogen with Cl. Okay, so this is the first two members of the homologous series having Cl. Okay, chloromethane and chloroethane. Okay, this is how you should answer. The same way, like first generate a homologous series having COH up to 4 carbons, okay. So what you can do, like just as I said, just think of the alkane, the first alkane, like few alkanes, CH4, C2, H6, C3, H8, like that. Okay, now what you can do, just replace one hydrogen with the functional group. So it will be C2, H5, COOH. Okay, so this will be like C3, H7, COOH. But remember, the COOH itself has one carbon, right? So this is not the one carbon acid, this is a two carbon acid, right? So what is a one carbon acid? To get the one carbon acid, the COOH itself has one carbon, right? So like what can we do? You subtract CH2 from the two carbon acid. So if CH2 goes from CH3, what remains? H remains. So this is your first acid. Okay, first like a one carbon acid. Okay, methanoic acid. So this is the first four members of a like series of carboxylic acid. Okay, so always remember, just think of the like alkane formula, replace the hydrogen with the functional group. That's it, you will get the series. Okay. Similarly, like a series, the first four alcohols. Okay, so just write the first four alkane. I hope it's clear now. C2H6, now C3H8, C4H10. This is the first four members of an alkane series. Okay, now just replace one H with OH. That's it. So CH3OH, C2H5OH. It's a two carbon alcohol. Now C3H7OH. So the OH is coming by replacing the hydrogen from an alkane. So C4H9OH, like that. Okay, clear. So you can expect this type of questions. So we'll do one more like with CHO. Okay, the same way you can do like CH4, C2H6, C3H8. Okay, now if you replace one hydrogen with CHO, it will be CH3CHO, C2H5CHO, C3H7CHO. Now, as we like discussed in the case of COH, CHO also having one carbon, right? The functional group itself has one carbon. Okay, so total this will be two carbons. So what is a one carbon aldehyde? Okay, so just write the aldehyde functional group. Now just subtract CH2 from this, so it will be HCHO. That's the first aldehyde, methanol. Okay, so this is the first four members of a aldehyde series. So if you ask to generate a homologous series like with a functional group, just think of the alkane formula. Okay, just replace the hydrogens with the functional group. You will get the corresponding required homologous series. Okay, I hope it's clear. And this is the one of the important type, like you'll be given with a set of compounds. Okay, and you may ask to identify the homologs from that. Okay, we just check when any common formulas are here. Okay, so generally what is the alkane formula? Cn H2n plus 2. Okay, so you can search for like anyone is obeying like this formula. So you can see like this one, okay, C3H8 double plus 2, okay, and C4H10 double plus 2. So these two are obeying this formula. So there are these members, right? C3 carbon, 4 carbon. The difference is CH2. The difference is CH2. They both belong to the alkane family. So they are homologous series. Okay. Then you for alkene formula. What is alkene formula? CnH2n. Okay. So just check for any compound is obeying this formula. So it's very clear that you have C3H6 is available. Okay. And you can also have like any other compound with the same formula, C4H8. Okay, C4H8. So both have a general formula CnH2n and they differ by CH2 unit. So they're also homologous series. Okay. Now you check for alkyne YNE formula. What is the YNE formula? CnH2n minus 2. Okay. So look at this like a C3H4 double minus 2, 6 minus 2, 4. So C3H4 is there. And you have C2H2 is also there. Okay, so write first C2H2. So here also you can see they have a common formula. They differ by CH2 units. So another homologous series. Okay. Now if for alcohol formula. Okay. So if OH is given as such, you can easily identify with OH. But here is nothing is given with OH. Okay. So how to identify the alcohol formula? It's already been discussed in the previous videos how to identify alcohol formula. Alcohol formula will be alkane formula plus O. Alkane formula plus O, that is double plus 2 plus O. Now check the compounds with the O. So you can see double plus 2 O. So this is an alcohol. So C2H6O. Okay. And this is not a double plus 2, like it's not fitting to that formula. Here it's double plus 2, like 2 plus 2. That's also fine. So you can write before that CH4O. Okay. So alkane formula plus O will be alcohol. So they also differ by CH2. So they're all like homologous series. Okay. Now how to check aldehyde or ketone? The aldehyde or ketone having what is the general formula? If you can see CHO, you can identify. Okay. Otherwise, like again, we discussed in the previous video, it should be an alkene formula plus O. Check for alkene formula with O. So you can see here, it's double and O. So that's a aldehyde CH2O. Okay. Then you can also see here double like 2 double hydrogen O. So C2H4O. So this is like belong to aldehyde series having a common formula, both like having a common functional group and they differ by CH2. Okay. And finally, what left? You have a C2H5Br, C3H7Br. Okay. So that you can easily identify because both having Br, they differ by CH2. So like that you can check the common formulas. Okay, you can easily identify the homologous series. Okay, so these are some possible questions that may ask. Okay, so I hope it will be helpful to you. Okay, so those who haven't subscribed, please subscribe and support. Okay, thank you so much.